Before the break, I left you with this quiz question. I'm not going to cover the first question because I've already explained that lots of times. But let's disentangle the income and substitution effect here. So to do that, as you know by now, you have to look at the new relative prices, but at the old indifference curve. So if you move the indifference curve inwards until you touch the original indifference curve, the budget line inwards until you touch new indifference curve, sorry about that, you end up at this point here, and if you've drawn that exactly like the book, you end up with 4 crackers and 14 chips. So the move from the initial situation to the new hypothetical situation, that's the substitution effect, and the remainder, that is the income effect, right? So because of the price decrease, I'm going to consume more crackers, but that's always the case. But the additional income effect also causes me to consume more crackers. So in other words, crackers are a normal good since as my income increases, I'm going to consume more of them. However, if you also look at this income effect, the income effect causes the consumption of chips to go down from 14 to 8. And also in the chips dimension, income has increased, right? But that has led to a decrease in consumption. So that means that for her, chips are actually an inferior good. Okay. So here that is explained once more. Next question now is we would like to get a grip on how much better off this person is due to the price decrease, right? Well, that's a simple measure we could have for that. We could compare utility levels, but as I already argued in the second lecture, those are not really informative. But the same logic, if we look at this income effect and substitution effect, so the substitution effect brings me to the same original indifference curve by taking money away from me, right? So the amount of money that you have to take away from me to get me to my original indifference curve, that's actually a pretty good measure for how much better off I am than I was before. And we call this a compensating variation. So in this particular example, you can figure out that this new budget line actually corresponds to to an income level of 17, which means that she is now better off by exactly $3 in this case, which is the difference between your new budget line and your budget line if pushed back to your original indifference curve. Good. So what did we do so far? We looked at this consumer's utility maximization problem, and then we first played around with the income level and did the angle curve and the income expansion path. Second, we played around with the price of the product, and to do that, we could by doing that we could derive the demand function and the income effect and the substitution effect. So the only parameter that's left to still play around with is the price of the other product, right? So let's do that now. So consider a consumer that consumes 2 products, Pepsi and Coca-Cola, and let's consider a change in the price of the other product. So this is my budget line. At the original prices, this is my optimal consumption bundle. So that means that I consume 4 bottles of Coke, 16 bottles of Pepsi. Suppose that the price of Pepsi doubles. So again, that means a rotation of my budget line. I can only buy fewer Pepsi bottles than I did before, from 20 to 10, consistent with a doubling of prices. And as a result, my new consumption bundle is here, 12 Coke for Pepsi. So in other words, the price increase of Pepsi causes me to consume more Coke. Consumption of Pepsi goes down from 16 to 4, so that's 75%. But the consumption of Coke triples, in other words, increases by 200%. So that means that these two products are substitutes, right? Again, the definition from the first lecture, if I'm not mistaken. If the price of Pepsi goes down, consumption of Coke goes up. So they are substitutes. When the price of a complement increases, then of course we expect consumption of the primary good to decrease. If we have tortilla chips and salsa, this is the original situation. If the price of salsa increases, then this is the new consumption bundle. And in this situation, you can see that due to an increase in the price of salsa, also the consumption of chips goes down. So in other words, these two goods are complements. So if you want to see it in a demand function graph, here it is. If this is my original demand function, then if the price of another product changes, then this demand function is going to shift. How it's going to shift? Well, if the price of a substitute increases, people now want to buy more of this good, so the demand function shifts outwards. But if it's a complement, the price increases, then people also want to buy less of this product. So in that case, the demand function for this product shifts inwards. And the opposite is true, of course, with a decrease in the price of a substitute and with a decrease in the price of a complement, as you can see here. Final section for this week. So I looked at a simple consumer's optimization problem that led to the demand function for this particular consumer. But now I'm interested in this market demand function, right, that I had in the first lecture. So to get market demand, of course, I just have to sum the individual demands of all consumers in the market. That's also what is stated here. So always be very careful how you sum them. So you have to sum them horizontally, right? Price is on the vertical axis, the cause is on the horizontal axis. If at a price of 5, I demand 3 and you demand 4, then total demand will be 7. So that will be the horizontal sum of those two curves. So here's a more concrete example. Consider the market for scooters. Here is your demand function. Here is the demand function of your cousin. What is your total demand function of the two of you? Well, he was at a price of 20. Your demand is 4. Your cousin's demand is 8. So total demand will be 12, right? At a price of 40, your demand is 3. Your cousin's demand is 3. So total demand will be 6. However, very important thing to keep in mind is that this demand function, this market demand function, will be kinked. Why? Well, suppose that we reach a price of 52, then your cousin's demand is 0, your demand is 3, so total demand will also be 3. However, at a price that is higher than 52, your cousin's demand is still 0, which means that market demand is simply coinciding with your demand, since you are the only one who actually has a positive demand. So if we are below the choke price of both, total demand is the sum of the two individual demands, but at a higher price, we only have the demand of the person that actually has a positive demand in this case. So at that choke price, we will get a kink in the market demand function. How does that look like analytically? So here's a different example. Suppose we have Jim and Alice, and they both have a demand for gasoline. Jim's demand is given by this. Alice's demand is given by this. Question, what is total demand? In these cases, always a good idea to draw a figure, as the question also asks here. The simple answer would be to just sum these two demands, right? So then you get 45 minus 8p. However, you have to take into account these choke prices. So this is what I did for market demand. That gives you 45 minus 8p, simply the sum of the two individual demands. But you have to take those choke prices into account as well. This part here was Jim's demand. So if you put that equal to 0, you get that his demand is 0 at a price of 5. So that's his choke price. For Alice, however, Alice had this part of the demand function also here. If you put that equal to 0, you get that her choke price is equal to 6. So at prices between 5 and 6, this is not the relevant market demand, because at prices between 5 and 6, only Alice has a positive demand. So we only have to look at her demand function. If we would simply add this part as well, then we would get, we would assume negative demand for Jim, right? And that doesn't make sense. By the way, I see there's a slight error on this slide. This should be 3p, right? And then everything makes sense again. I will change that before I put it on master. So that brings us to the real market demand. That's the sum of the two for prices below 5 and only Alice's demand at a price higher than 5. So that's what this looks like. Again, you get a kink at the choke price of Jim in this case. Here we have the sum of the two. Here we only have Alice's demand. Which brings us to the quiz, the last quiz of today. Very similar setup. Suppose that we have a market for cinema tickets, two types of consumers. Students have a demand of 100 minus 20p, so this is not really an individual demand, but the demand for one segment of the market, if you like. And regular people have this demand function. Question, what is total demand? And, of course, beware of the kinks. Answer after the break.